We have two different routing protocols today, OSPF and EIGRP. We're going to get them working together right now. Hey guys, welcome back. So we're going to be doing a quick lab today. It's going to involve 3 routers and 2 switches. We're going to be looking at creating VLANs, routing those VLANs in a switch core environment, and then doing route redistribution between OSPF and EIGRP. So again, this channel is about everyday IT. Came across my work today where it involved route redistribution. I was like, let's lab that up and create a video. We're going to be doing this on physical equipment today, not packet tracer, not GNS3. So let's get started. So as you can see here from this screen, we have 3 routers and 2 switches. Switch 1 and router 1 are running OSPF. Router 3 and switch 2 are running EIGRP. And router 2 is going to be where the real magic happens, and that's going to redistribute the routes between EIGRP and OSPF. We're going to see that. We should receive the redistributed routes on the switches and on the routers to respective sides. So we're going to walk through this VLAN creation. We're going to set up some basic EIGRP and OSPF routing protocols, and then we're going to really tackle the route redistribution. So it's probably going to be 2, maybe 3 videos in this little segment in this lab, but this is something that came across my desk today. I wanted to really hit it and lab it up, so let's get to it. Okay, so as you can see, we're on switch 1. So we're going to do a show run. I'm going to show you the basic configuration I did to all of these devices. I changed the host name. I ended up doing no IP domain lookup. And then I ended up doing the login synchronous. Okay, so we should be good there. So let's go and create some VLANs. So we're going to do VLAN 10, name user 1, VLAN 20, name user 2, VLAN 30, name user 3, and VLAN 40, name WAN. Alright, so if you do a show VLAN brief, you can see those VLANs are created. Now let's create the SVIs that go in with them. So we're going to do interface VLAN 10, IP address 10.10.10.1, 255.255.255.0, interface VLAN 20, interface VLAN 20 if I can type, 10.20.20.0, 1, there we go, interface VLAN 30, IP address 10.30, oops, 1, there we go, and then interface VLAN 40, and we're going to do an IP address 10.0.2.0, oops, 2.2, yeah, 2.2, we're going to end and write it. We're going to do a show IP interface brief. Alright, so right here you can see 10.10.10.1, 10.20.20, 1, 10.30.31, 10.0. Typo right here, VLAN 40. See? Configure and always verify. So we're going to do an IP address 10.0.2.2 on this. And then we're going to do a show IP interface brief. 10.0.2.2. Looks good. Okay. So just so we can get these, we're gonna assign a trunk port. Okay. Config T, interface VLAN 10, no shut. Interface VLAN 20, no shut. Interface VLAN 30, no shut. Interface VLAN 40, no shut. Okay. just see if we can enable those quick. Okay, and they are showing up. Were they showing up before I even looked at it? They were. So I just did that for no reason. That's okay. No short commands always help. Okay. So, as you can see here from our topology, we have interface 101 going into the router. So we need to put that VLAN, or put that device, or that interface in the VLAN. So we're going to do that real quick. So, config T, interface 101, switch port mode access, switch port access VLAN 40, and write. Okay, so we did that, and then we're going to do router OSPF 100. Oop. Got to enable IP routing first. There we go. And let's see, we're going to network 10.10.10.0, then 255, area 0. And we're going to do that same thing, but we're just going to replace these with 20s. Oops. There you go. And then 30s. So, and then we're going to replace this with just a 2. There we go. We're going to just write it quick. Okay. So that is the base routing. Okay. Again, we're going to do the base routing first. Okay. And then we're going to do the network statements doing that. Okay. Now, once we go into redistribution, we're actually going to wipe out those network statements, and we're going to use prefix lists. But what I want to do is between the switch 1 and R1 and switch 2 and R3, I want to establish neighbor relationships with either OSPF or EIGRP with those standard network commands in that router configuration to show how you would do that normally. And we already wrote it. So now we're going to go over to R1. Oops. There you go. So R1 right here. Okay. And we're going to go to interface. Okay, and then we're going to do an IP address 10.0.2.1 to ping 10.0.2.2. Not poing. Man. I'm typing real quick today. You can tell I'm not on a keyboard I'm used to, or not used to. Okay, let's try that ping one more time. There it goes. Okay, just had to wait for it to establish. Alright, took a little bit. Old hardware. Okay, we're going to go to router OSPF 100. Now, that OSPF 100, that is the 100 number. Okay, so we're going to do, let me do this real quick. So router, and you can see we have all different types of routing protocols. If you do OSPF, you have that process ID, okay? That process ID is locally significant only, which means I could put 300 on this router, and it would not make a difference with neighbor relationships. It wouldn't even show in the other devices that are running OSPF. What really matters is when we do the area, right? So router OSPF 100, then we're going to do network 10.0.2.0, 255, area 0. That right there, that area is what makes that difference. And then right there you can see, man, that neighbor adjacency came up real quick. So do show IP OSPF neighbors. Right there, full NDR, awesome. All right, cool. Okay, so if we do exit and show IP route OSPF and show IP route OSPF, show IP route should be routing those interfaces. So 10.20.20.1. All right, so let's see. What was that? 4. We're going to do a little bit of troubleshooting here. Show IP protocols. So right here, routing process 10.30.31. Okay, show IP protocols. So it says I'm routing for interfaces, probably because nothing's connected to them. I would say probably because nothing's connected to them. Let's go back to router 1 quick. Okay, and router 1, show IP route OSPF. Yeah. Alright, so I'm going to pause the video real quick and go over there. I'm going to plug in another device and create a trunk port between switch 1 and I guess switch 3. So once I do that, I'll bring that switch back up and we'll resume the video. Alright guys, so we got 2 more devices turned up. Switch 1 is now connected to switch 3. Switch 3 and switch 1 have a trunk port going in between. Switch 3 has an IP address. Switch 2 and switch 4 also have a trunk port going in between, and they have an IP address. Well, excuse me, they don't have an IP address yet. We haven't got back to that. It will have an IP address. So we're going to take a look at the topology with modification, and hopefully this will get us to be able to see those local routes on that router. If you take a look at this topology, you'll see switch 3, switch 4 are connected, and the port 24 is being utilized for that trunk interface. So let's take a look at the config. So right now we're just on router 1. I just want to do a quick show IP route OSPF. And there we go, we are seeing those routes. So, and what I will do right now is I'll go back to switch 1 and do a show run section, or hold on, show run interface GI 10. Ooh. That's all I did, and I only did that on, hold on, 24. That's all I did, and I only did that on the layer 3 switch. So I specifically said I wanted a trunk. I specifically said I wanted it .1Q. And because DTP is running on switch 3, it automatically formulated that trunk. You can validate that by doing the show interface trunk command. And you can see right here, the gigabit Ethernet is 1024. It's on. Encapsulation is 802.1Q and it's trunking. Right. And then you can see here VLANs in spanning tree that are in the forwarding state 1, 10, 20, 30, 40. And we will go over to switch 3 right now. And if you are curious what I'm trying to do, I'm actually looking underneath my mic to look at the keyboard. we have to do a keyboard shortcut to flip between these devices quick. So we're going to do a show interface trunk. And right here you can see where it was auto. Right? Alright, so you can see, as you can see, it's trunking. It's 1, 10, 20, 30, 40. Probably last time we're going to be in that device. So let's go back to R1. Show IP interface, show IP route OSPF. And we are seeing those routes across. So ping 10.20.20.1 works perfectly fine. So now what we need to do is we need to form that adjacency between router 1 and router 2. Router 1 and router 2 are utilizing a copper connection as well. So let's go to fig T interface GI 0/0 no shut IP address 10.0.1.0. Oops. There you go. Okay. And I'm going to exit, and then I'm going to do router OSPF 100 and network 10.0.1.0. Enter that wildcard mask. So I'm doing all these commands quick for the EIGRP and OSPF. I have a playlist on this channel, right? That you can see. It's utilizing Packet Tracer. We're actually going to go in depth with these network statements, with how to get neighbor adjacencies, what the requirements are, how to troubleshoot those. So if you're looking for more detail as what's going on with these network statements, go visit that playlist, right? Like and subscribe below, and we'll get back to the configuration.